Welcome to Orca. Today we are looking at how to classify critical points of a function. So, solution. To find a critical points of a function, we have to get the partial derivative of that function and equate it to 0. So, if it is undefined, then it doesn't have solutions. So, but this one is a polynomial, as we look at dx dy of this function. That would be dx of all that 3x raised to power 3 plus 3xy plus 3y squared minus 6x minus 3y minus 6. Now everything that doesn't have an x in it is considered constant. Like that, those one will go. So when you differentiate a constant, it's always 0. So what we have here, what we have there is 3x squared plus 3y minus 6. Now we equate it to 0 to get x and y. So this is 3x squared plus 3y is equal to 6. Both side by 3, both side by 3, both side by 3. So what we have here is x squared minus y is equal to 2. So make this plus, this is plus, make this equation 1. So let's do the function here with respect to y. So that is dy. So again, that would be x to the power of 3 plus 3xy plus 3y squared minus 6x minus 3y minus 6. Then again, whatever doesn't have a y in it is considered constant. So that will be 0 when we differentiate it. This will be 0. That will be 0. So what we have here is 3y plus 6y, no, 3x, because minus 3y, that will be equal to 0. Just to get another solution, or simplify it. So both sides by 3 again, so x plus y minus 1 is equal to 0. That means x plus y is equal to 1. Now we have to solve for x and y. So solve for x and y. So we have two equations here. So we have x squared plus y is equal to 2, and then x plus y is equal to 1. This looks like 2. Okay, yeah, I missed 2 there, 2 here, and there has to be 2 there. So in this case, this means 1 minus 2y is equal to x. So substituted into this equation, that would be 1 minus 2y squared plus y is equal to 2. Now you can multiply it out and you will get 4y squared minus 3y is equal to 1. Now this is a quadratic equation. You can solve it with using a quadratic formula. Y is equal to 1 and negative a quarter. Now you can solve for x. We know x is equal to 1 minus y. 2y is 2y. So if you plug it 1, you will have negative 1 as x1. Then x2 here, we will have minus 2 into bracket there. We have negative quarter. So this will give you 1. 2 times a quarter, 4 will give you plus half. So this is 3 over 2. Now we have found our critical points. So these are critical points. One is -1, then the other one is 3/2. This is -1/4. Now we have to find the double derivative of that function to classify them now. So what we will do is dx, dy will classify the function if it is a minimum or maximum or saddle. So we will have d squared with respect to dx times d with respect to y squared minus of that function over dx dy. So let's find the double derivative now. So we go back to our thing. We have d will be equal to dx of what we found already, which is 3x plus 3y minus 6. So constant will always be 0 too. So 6x is our answer. This is considered constant because we are differentiating it with respect to x. So the first one here is x 6x. So the other one is 2 dy, this dx. This will be equal to dy of the dy we got before, which is 3x plus 6y. So if you differentiate that with respect to y, you get 6. So let's look into that. Let's get that one. This one is df dx dy. So that is d over dx of dy. So what is that? So we can just say dx over dy is the same as saying dx over the partial derivative of the function with respect to y, which is 3x plus 6y minus 3. So this, with respect to y, with respect to x, with respect to x. With respect to x, all this one will be constant, so all of them will tend to 0. So we have 3 here. Now putting it together, that is d squared f over dx squared dy squared minus d squared over dx dy squared. So let's see. We have, for this one, we have d of dx times d of dy squared minus dx dy. All this squared. So this will be equal to, we got 6x on dx part, and then another 6 on dy part minus 3 squared. So we have 36x minus 9. Now we're going to check for whatever point we have found there. So A, we have the point was -1, +1. So plug it in. So plug it in there, we have -36 minus 9 will be less than 0. This point is saddle point. This is where the function changed from minimum to maximum or vice versa. So number 2, let's check that equation at -1/4. So plug it in there is still like 36 times 3/2 minus 9. This goes to that one is 18. 18 times 3 is 54. So this one is greater than 0. That means this is a local minimum. Local minimum. Yeah. So that's what we had to do. We don't have a maximum. Thanks for your time.